What if, right now, without warning, the sun just vanished? Not exploded, not turned into a black hole, just gone. No sunrise tomorrow, no light, no warmth, just infinite darkness creeping over the planet like a silent wave of death. Within minutes, the skies would turn black. Within hours, temperatures would plunge. And within days, humanity would be fighting for survival in a world where time, weather, and life itself fall apart. You've never seen chaos like this. But this isn't just imagination. Science knows exactly what would happen, and it's more terrifying than any movie you've seen. Let's dive deep into the apocalyptic chain reaction triggered by the sun's disappearance, from orbit mechanics to mass extinction, from nuclear survival bunkers to a future frozen Earth. This isn't just a story, it's a warning, and it starts now. What if the sun suddenly disappeared? The final 8 minutes, a silent countdown to darkness. The moment the sun disappears, we wouldn't know it, not immediately. That's because light from the sun takes approximately 8 minutes and 20 seconds to reach Earth. So for a little over 8 minutes, everything would seem normal. The birds would sing, the oceans would sparkle, and we'd continue our lives blissfully unaware that the sun was already gone. But in that final countdown, the solar system would already be falling apart. Gravity, which propagates at the speed of light, would vanish alongside the light. Earth, no longer tethered by the sun's gravitational pull, would begin to drift in a straight line into deep space. The planets would unravel from their orbits, like pearls falling from a broken necklace. The celestial harmony we take for granted would dissolve into cosmic chaos. Then, precisely 8 minutes later, darkness. A complete, suffocating blackness, unlike anything we've ever experienced. The sky would go black, not twilight, not night, but an absence of light so total it would feel like the universe had been erased. Stars would remain, distant pinpoints of light, but the sun's overwhelming brilliance would be gone. The moon, too, would vanish from view, as it only reflects sunlight. Within moments, panic would ripple across the planet. Electricity might still work, satellites would still orbit for a while, but the psychological blow would be immense. Something fundamental would feel broken, because it would be. But the horror is just beginning. In the next chapter, we explore what happens to Earth's temperature, atmosphere, and oceans as the clock ticks into the first hour of eternal night. The first 24 hours, freeze begins. The sun's warmth doesn't disappear instantly. It lingers for a short while. But within hours of the sun's disappearance, Earth's temperature begins to plummet. By the end of the first 24 hours, the surface temperature could drop to below -17 degrees, 1 degree Fahrenheit. Cities would begin to freeze. Without sunlight, solar panels would be useless, and energy infrastructures would face a strain. Most vegetation would begin to die, deprived of the light needed for photosynthesis. Without plants producing oxygen and absorbing carbon dioxide, the atmosphere would begin a slow and silent transformation. As the temperature continues to fall, the oceans would start to freeze, not from the top down, but from the surface inward. Eventually, the entire surface of the sea would become a thick sheet of ice. However, due to water's thermal properties, it would take months, maybe years, for the entire ocean to freeze solid. Life beneath the surface might continue for a while, nourished by thermal vents in the deep ocean, but surface life would struggle almost immediately. Humans, now faced with a dark, freezing world, would scramble for solutions. Underground shelters, geothermal power, and fusion technology might offer brief pockets of survival. But panic, resource scarcity, and environmental collapse would likely trigger social upheaval. Civilization, as we know it, would be in a race against the cold, a slow-motion disaster that no one could reverse. And yet, this is only the beginning. Next, we explore how the disappearance of the sun disrupts Earth's magnetic field, atmospheric pressure, and even the length of time itself. The collapse of Earth's shield, magnetosphere and atmosphere in peril. The sun doesn't just give us light and heat. It also fuels the magnetic cocoon that protects Earth from cosmic and solar radiation. Without the sun's charged particles constantly interacting with our magnetosphere, this invisible shield begins to weaken. Over time, Earth becomes increasingly exposed to galactic cosmic rays and deadly radiation from deep space. With our magnetic field disrupted, auroras would vanish and dangerous particles would bombard the planet, increasing the risk of cancer, genetic mutations, and widespread electronic interference. But radiation isn't the only threat. The atmosphere, once held in balance by solar energy, would to collapse. With no solar heat to stir the winds and drive the weather, Earth's atmosphere would start to stratify. Wind patterns would cease. Jet streams would slow and fade. Weather systems, those vast swirling engines of clouds and pressure, would grind to a halt, replaced by stillness and silence. The atmosphere would begin to condense and shrink as cooler temperatures pull air molecules closer together. Oxygen levels could become uneven, leading to breathing difficulties. As high-altitude clouds freeze and drop, the sky may begin to look more alien, thin, metallic, and silent. The global climate machine would stall completely. There would be no seasons, no storms, just a deepening cold and a haunting stillness. And time itself? It may not slow in the literal sense, but our perception of it surely would. With no sunrise or sunset to mark the passage of days, human timekeeping would fall into disarray. Circadian rhythms would vanish. Clocks would lose meaning. Psychological health would degrade. We would be unmoored from the most ancient rhythm we've ever known, the rise and fall of the sun. But the worst is yet to come. In the next chapter, we dive beneath the ice to see how Earth's core responds to a world gone dark, and whether the planet itself might tear apart from within. Deep Earth awakens. When the core starts to die beneath Earth's frozen crust, lies a restless giant, the planet's molten core. This spinning sphere of iron and nickel generates Earth's magnetic field and plays a key role in plate tectonics, volcanic activity, and the very heartbeat of our planet. But in a sunless world, the core too begins to change. Though it doesn't cool overnight, the lack of external heat from the sun means the temperature gradient between Earth's surface and its interior starts to shift. Over decades, perhaps centuries, this shift disrupts the geothermal balance. The Earth's internal dynamo could slow, weakening the magnetic field even further and accelerating our exposure to cosmic radiation. Without the gravitational pull of the sun to balance Earth's orbit and rotation, tectonic activity becomes unstable. The planet is now drifting freely through space, and that motion, combined with the cooling of the crust, could cause stress fractures across the lithosphere. Earthquakes might grow more frequent and intense, driven not by tectonic collisions, but by internal imbalance and shrinking crust layers. Volcanic eruptions, once part of a rhythmic cycle of planetary regulation, might become unpredictable and catastrophic, spewing ash into a sky already devoid of light. Deep ocean thermal vents, once a haven for life, would begin to flicker and fade. As geothermal activity slows, even the last redoubts of living ecosystems, those clinging to cracks in the ocean floor would begin to perish. Life itself, once sparked and sustained by the sun, now finds its final embers smothered under ice and ash, the mantle beneath us slow-moving. Viscous rock could begin to seize. Without a surface temperature gradient to help drive convection, mantle plumes could freeze in place. Plate movement might cease altogether. Earth, a planet once alive with motion, heat, and rhythm, begins to die from the inside out. But what happens to humanity as the planet's heart stops beating? Do we adapt, migrate, or perish? In the next chapter, we explore the desperate last stand of civilization, the technologies we might invent to survive, and whether our species can build artificial suns to keep the flame of life alive.